Hi there, Amir here. If you stay until the end of this video, I will show you which companies are using merge to sorted lists in their interview questions. This one is labeled as easy, but over 900 people in the comments in LeetCode, which I will show you, have said that how is this an easy one? It's not one of those very easy questions to solve, but let's jump into this. Let me first clear this up. I'm using a Jupyter notebook on the right-hand side in black, and I'm gonna have LeetCode itself in white. Let's just scroll down to the comments section. As I said, I'll show you which companies are using this problem later, but for now, let's look at the discussion. Subra in 2023 says, I think this should be a medium problem. I agree with you, mate. 417 people have upvoted it. It's definitely a medium question, Say says. And Prince Vijay says, I didn't understand the class given above. Can anyone explain? I will do it. Listen to me. I'm not going to really read through these comments, but what I wanted to tell you is what is actually this problem asking me? I will break it down into visualizations. I will draw it, but let me read it quickly for you. You're giving the heads of two sorted linked lists. If you don't know what linked lists are, the link is up the top right. I created a very good video. In my opinion, you can tell me that I wasn't really a good video that talks about linked lists and list nodes within them. So it's very helpful to put that to set the scene. So right now, merge the two lists into one sorted list. And I think the word sorted is a key here because they are both sorted as given to us, and also the result needs to be sorted. So if you've already got something that is sorted, why would you mess it up? So that's one key that you need to be aware of. The list should be made by splicing together. So if you don't know what the word splice means, I think a lot of people also in the comments said they don't know what splice means. Splice means do not create new nodes. Take the two linked lists that you have and kind of merge them without creating any new nodes. It's so easy with linked lists. I'll show you. All right, and this image kind of shows what we're being asked. So we have this list number one, and we have this number two. What we have been asked is to merge them in a sorted way. So when we talk about sorted, I think you would agree that either this one needs to be the first one or this one, whichever goes next, the other one goes second. And then we want this to be next, and we want this to be next, and either this four or that four doesn't really matter. We want them to be number 5 and 6. And eventually you will have 1, 1, 2, 3, 4, 4. This is what we've been asked. Now, before further ado, I want to run you through really quickly what is a linked list and why do we do this. But as I said, the link is up the top right for my full video on linked lists. Let's get into it. When we talk about a list node, which is one element of a bigger linked list, you can imagine that, for example, 1, 2, 3, each of them is a list node. So let's talk about this number 1. This node has got a value and it has got a pointer. Value is number 1. So here we're talking about value equals 1. And the pointer is actually what comes next. So the pointer for this node is this number 2. In other words, if I were to complete this, I would then go ahead and say, okay, then the second one, value equals 2, and the pointer, the next one, which has the value of 3, and the pointer goes to actually none, because that's the end of it. So this one, the pointer would be none. We don't really use the word pointer when we define a class. We normally talk about the word next, and also next. So there are two things that we talk about, value and next being the pointer. This is quite important because it allows us to navigate a list without really assigning a memory for each of those nodes. Whereas here, what we're doing, we're saying, hey, this one is number 1 and it points to next one. That one is number 2 and it points to number 3. So let me just clean up this screen and I will write exactly the same thing in a class. Okay, let's define a class of list node. We are defining what a list node is here. So using a function of init, I am initializing a function that takes the node itself, and it sets the value to 0 because we're starting from nothing, and then we can add data to this. This is considering that we don't have any data, and the next goes to none. And this is the definition of an empty node. The value is 0 and it's not pointing to anything. But if you were to define anything, you wanted to put some value and pointer there, what then you would do is to assign to the value that the user might give you, and assign the next to be any point which could be of object next. Okay, now that you have created the class, what we need to do is create node 1. So I'm just going to call this node 1, and I'm just going to create node 2 and node 3. I know that I'm not drawing the best, and I will put 1 here, I'll put 2 here, I'll put 3 here. I'm not going to connect them yet because I will have to explain it to you how to do it. But for now, let's create node 1, node 2, and node 3. So for us to create node 1, this is what I'm going to do. I'm just going to say node 1 is 1, and node 2 equals list node of 2. They're not really connected. They are completely separate from each other. And node 3 is list node of 3. It could be list node of 300, 1500, whatever. So that 1, 2, 3 doesn't have to do anything. Now, once you run this, they are still separate from each other. They're not really connected. Now I have to connect them. Well, how do I connect them? If you look at node 1 and look at its value, you will see that the value is 1. That's what we wanted. And if I look at the next, you will see that doesn't have any next because there is no connection between node 1 and node 2. So what I will have to do right now, let me bring up my pen. I will be coming in here and I will define this pointer. How do we define this pointer? If you want to connect the pointer of node 1 using the dot next, all you will need to say is, hey, the next for node 1 is node 2. If I run that and I show you node 1 dot next now, you will see that it's actually pointing at the list node, which means that this connection is set. I will have to move and make the next connection. In that regard, I'll come here and I'll make this connection, pretty much doing the same code. It means that node 2.next equals node 3, and that connection is also set up. So now you understand that the connections are set up. How do we now merge two list nodes or linked lists into a one single merged or spliced linked list? Well, to do that, I just need a black screen. I'm just going to scroll up. Now that I've got my blackboard, I'll say, based on the LeetCode example, list 1 is number 1 pointing at number 2 pointing at number 4, and list 2 is again number 1 pointing at number 3 this time, pointing at number 4. So how do I splice these two together, which means that I'm not going to be able to create any new node. I will have to change these pointers so that I can get 1, 1, 2, 3, 4, 4. Let me show you how it works. So if I put L1 here, right, to show that L1 is here and L2, I will need a third container. So I'm just going to call my container current, right? And this current will help me to traverse across these nodes and merge them and sort them together. Well, they are already sorted. I said that because they are already sorted, it just makes sense for us to use that. I will show this sorting in green so that it's just separate. What you really need is an empty node or a dummy node for you to take as the head. Because if you do not have any heads, or if you don't have any dummy nodes, it's going to be difficult whether you start with jumping in here or in here. But if I create a dummy node and I call it dummy, right? I can start going in that direction or in this bottom direction. Doesn't really matter. They are the same chance. So I'm just going to go in here because why not? So if this dummy moves in here, what will happen? We will move L1 to the next one, and we will make this one current. This is very powerful because now I have moved my pointer of L1 to the next one, and I can say that I'm traversing across the first node. Now, okay, this one is 1, and I will capture that number 1. And do I go that way or do I go down way? Well, this is number 1 and it is a smaller number 2. So I will just cross this L2 out. I'll put L2 in here and I will make this one current now, which means this goes in this direction. Now that we have gone in the bottom direction, we will capture another number 1. And now do I go to number 2 or do I go to number 3? Well, 2 is smaller than number 3. This pointer points at this one. Now L1 will have to move to the next one, and this one becomes the current. As you can see, we have gone from 1 to 1, then 2. So let me write down 2. And once I have gone here, do I go down to 3 or 4? Well, of course, number 3 is smaller than 4. So cross L2 and move L2 in here. And this one becomes the current. Okay, so I'll capture number 3. Now, do I go to that 4 or do I go to this 4? It doesn't really matter. They're the same values. So I will just make it to this 4 and L2 goes, so current, capture number 4. And once I have done that, I will just go up and I will push this L1 out, which is again in the world of none, and this becomes current. And then after there is nowhere to go. I'll just continue to none. This way I will have captured another 4. So hopefully this makes sense. So what we did, we started with a dummy node. We started in here. Then we moved to this one because it doesn't really matter if you go to this one or that one, doesn't really matter. So we crossed out L1, made it current, and then moved down here, took this number 1, made it current, went down here and picked that number 2, then number 3, then this number 4, and then this number 4. And that has given me the merged form of 2 linked lists. This is very powerful and hopefully it makes sense. Now all we need to do is put it in code. So let's go ahead, clear the screen. What I want to do, I want to get exactly what code I have been given here. So let me copy that. That's from LeetCode. You can see that a class solution has been defined. All I have to do is to make this function. For me to define that function, let me just make it an easier form. Then I will go back to the full form. I will be getting a list 1 and a list 2. Before I write this function, what I want to do is run you through a quick graphical explanation. So we have got list 1. It has got 3 nodes, and they are pointing at the next one all the time. And we have a list 2 pointing to the next one, and that's it. So this is your list 1, and this is list 2. What I said, we will be creating a dummy node. So let's create a dummy node. I will write dummy in here. So let me go back to the code and introduce the dummy node. So dummy equals list node of 0 because it is empty. We're not really using it. And I will also introduce a new variable called current, and I will put dummy inside current because I want to start there. So now if I go in my graphics, you will see that I either have to go up or I have to go down. So let me write down the values. The values that we had, let me just write them in purple again. So this one was number 1, this one was 3. I think no, that wasn't 3, that one was 4. And this one is 1, 3, and 4. Now the decision we have to make is whether this dummy, which is called the current now, does the current go that way to this one or to this one? Well, I need to do a comparison. Let me show you what the comparison will be. I will have to say, hey, so if the value of list 1 is smaller than the list 2 value, then what I want you to do, let me show you in graphics. So if you're saying that this one is smaller than this one, which in this case it's not, but let's imagine what we want to do, we want this current to move that way, and this L1, which was sitting here, to move in here. So this is what we have to do. Let me write it in code. In code, we will have to say, if this is the case, if list 1 is smaller than list 2, what we want you to do is to take the current next to list 1, which means that, hey, I want you to go to this direction, in that direction. And once we have created that pointer for current, we also need to put list 1 inside current. This is very important because the first line, this line, creates this pointer. We're just creating that pointer. Once we have created that pointer, we are actually moving current to here. That's why I drew this line on top of it. So once you have done that, now list 1 has to move to the next one. Now that we have moved the current, we have to move list 1 as well. So list 1 goes to the next one. So the pointer goes to the next one. That's exactly what happened. But this was the case if list 1 was smaller than list 2. If it was the opposite, well, we will do exactly the same for list 2. So current.next will go to list 2. So I'm moving the pointer for current going down. And then once I have moved that, I will set current as to be list 2. And for list 2, I will create a pointer to go next. This is list 2. Theory, what we are saying here is that if this is smaller, don't do that. Your L2 that was sitting here, move this to the next one and make this current and come this way. And maybe you will go that way or you will go that way. So we have two options. We will either go that way or that way. So it really depends if this is smaller or this is smaller, but you get the idea. There is one thing that you should be aware of, because what if list 1 or list 2 are empty? This is very important. What I kept until now is we have to say, I want you to do all of this while list 1 and list 2 are not none. So all of this has to happen while both of them are not none. So you might say, hey, what if one of them is not none? Well, that means that we will have to come out of this wall, because if one of them is not none, if one of them is none or both of them, we will have to say, hey, I want you to take the next pointer of current, because current was the dummy, right? Current started as an empty node and we set it to dummy node in the beginning. And then we will point it to list one if list one is valid. Otherwise, we will point it to list two. And once done, we will return dummy.next. Now, if I show you, if I paste this code into LeetCode, let me copy that and I will put it under here. Let me just make this a bit larger. I didn't have the first line. I just need this line. Copy that. Let me zoom out a bit. It's just for your view, but now I'm struggling. So if I take all of this, move them forward. All right, now I'm going to move my face to the other side and run the code. Fingers crossed it will be correct. Yeah, 3 cases are correct. And if I submit the code, hopefully all test cases are correct. Let's see. Yeah, it says accepted. Look at that. 100% accurate. All the 208 test cases pass, which is very good. So as I promised, I will show you which companies are actually using this problem. Let's scroll down to problems. Let's scroll down to companies, and you will see that in the last 0 to 3 months, Amazon has used it 11 times, Google 9 times, Bloomberg 8, and such. Apple has used it in the last 6 months. HubSpot has used it in the 6 month. I really hope that you enjoyed this problem. If you haven't seen my video on linked lists, I really encourage you to watch it. It will help you to understand this problem. And let me know if you have any questions. I'm more than happy to help and answer questions if you may have. If you already haven't subscribed to my channel, please do. It really helps me grow my channel. And I'm hoping to create more quality videos. And I'm really excited to be part of your learning journey. Thank you very much.